Hello everyone, welcome to this video lesson. In this video lesson, today we are talking about a topic called ballistic pendulum. So first of all, let us try to identify what do we mean by a ballistic pendulum. It's a kind of a heavy mass like a wooden log suspended from a rigid support with the help of a wire. It's like a pendulum who is able to oscillate when we disturb it. And using this device, ballistic pendulum, we can find the velocity of a bullet. Let us see how can we do that. So let us consider first of all a ballistic pendulum with a rigid support, a unstretchable wire. Let the length of the wire is known for us L, a heavy mass like a wooden log is suspended. Let that mass is capital M. It is in the state of rest. Assuming it like a second body, it is in the state of rest. Let us consider a bullet, a smaller one, whose mass is m, who has some initial velocity u, is fired horizontally into this system. Let us assume the collision is perfectly inelastic. The meaning of inelastic is after the collision, both the bodies will have same velocity. That means these two bodies will move together with a common velocity. That means this bullet actually go and embed into that wooden block itself. Now, as there is no external force acting, we know the linear momentum of the system is always conserved. That means initial linear momentum of the system is final linear momentum. Initial linear momentum is initial momentum of the bullet mu. Initial momentum of the block is 0 because block is initially in the state of rest. Let they together are moving with a common velocity v. They are now these two are moving with a common velocity v. So taking that into consideration, we can further simplify mu, that's the momentum of the bullet, equal to m plus m of v. That implies the common velocity acquired by both of them being a perfect inelastic collision is capital M plus small m. We want to calculate this common velocity v itself using this ballistic pendulum scenario. Now, as this point is fixed, the entire system slightly get deviated from its main position. Let the system has moved to a new position. Now, who has moved to a new position is both of them together. So, when compared with the initial position, it has assumed like rise to a height h and stop. That means that's the maximum height reached by it. Now I can say at this point it is having velocity and hence kinetic energy. At this point its velocity v dash is 0. It is raised to a certain height. That means all that kinetic energy is simply converted into potential energy. So what I can say? Kinetic energy when they together has a velocity v has velocity v equal to potential energy of that system, that is they together, yet maximum height that it has reached. Let me assume that maximum height equal to h. So here I am simply applying the law of conservation of energy, that energy of a system is always conserved. It is neither created nor destroyed. It just converts from one form to that of another form. So kinetic energy is when the bullet and block moving together half. As they are moving together, m plus m. They had a common velocity v square as we have assumed. They together have raised to a height m plus m of gh. So I can cancel this m plus m. So half of V square equal to GH. That implies V equal to root 2 GH. But we already know V in terms of the masses. So substituting this value of the V here, as we know V is mass of the bullet into initial velocity of the bullet by mass of the bigger block and mass of the bullet equal to root 2 GH. Our aim is to calculate the velocity of the bullet, U, initial velocity of the bullet. So I can write initial velocity of the bullet is m plus m by small m into root of 2gh, where h is the height raised by that block and bullet together with reference to mean position. Sometimes it may happen that he may don't give you the value of that h to you in the problem. Rather, if he says, because of that, if this wooden block makes an angle theta with vertical, if it is given like so, just in case, if angle with vertical is given for us, but h is not given. Now we need to express this h in terms of an angle theta. I will just replicate the diagram, redraw the diagram here. This is where initially both of them are there. Now they have raised to a certain height. When compared with the mean position, that height is nothing but equal to h. In this process, there is an angle theta. Now I can say, being that is theta, this value is also equal to theta. So let me just name the things like A, B, C, D, E. I want to express the h in terms of this theta. So it's very clear that the height raised DE is nothing but BC itself. I can express that BC as total AC minus AB. AC is nothing but length of that ballistic pendulum L itself. AB I don't know, but I know AD is also the length of this ballistic pendulum. This is also the length. Nothing changed, right? So, but I can see there is a right angle triangle. It is right angle now. The right angle triangle ABC. I want AB, who is being a adjacent side to theta. I will write cos theta as AB by AD. Cos theta is AB by AD is nothing but equal to L. That implies AB is nothing but equal to L cos theta. I want to calculate BC now. BC equal to AC minus AB. AC is nothing but the total length. AB is nothing but, as we have proved, L cos theta. So BC is nothing but L of 1 minus cos theta. That's nothing but D. That's nothing but H. So if theta and L is given for you and H is not given for you, in that case, I can write U using this equation now. Capital M plus small m by small m to root 2g. Instead of h, I can write L of 1 minus cos theta. Like this also we can express the velocity of the bullet and find out the velocity of the bullet. So ballistic pendulum is a device which is useful to find the velocity of the bullet. I am firing the bullet with a velocity u, and I am expressing that u in terms of the mass of the bullet and the mass of the block, in terms of the angle and length of the block, length of that ballistic pendulum, or the height raised by that system. That's it. Thank you for watching. Keep coming back for more and more video lessons. Thank you.